Hey class, Mrs. Anderson. This video is on solving system of equations by elimination. So this is the third method that we've learned for solving systems of linear equations. So first off, to do elimination, what do you need? You need the terms, or I should say, you need the like terms in the equation to line up. So here's an example. So you can see that the x's are lined up, the y's are lined up, the constants are lined up, and not only that, but the operations and the equals are also lined up. So that's an example. Here's a non-example. The x's are lined up, the y's are lined up, the constants, but you do not have the operations lined up. Here's the plus and the minus, and the equal are over here. So this is an example on the left is what you want it to look like. Everything, all the like terms line up in the equation, and then a non-example, it's not lined up over here. Okay, so keep that in mind. The second thing you need is one pair of variables to be opposite. So for example, 3 and -3 are opposites. So if I have a 3x, I would also need a -3x, because when you add 3x plus -3x, it equals 0. So that's how you eliminate them. So you need them to be opposites. If you do not have one pair, at least one pair of opposites, then you can make them opposite by using multiplication. Okay, so we start out with example 2, and we have it nicely lined up, 5x, 6y's, the equals, everything's lined up. And we also have opposites. We have opposites because we have a -6y and a +6y. So once you have opposites, what you do is you add the equations together then. So 5x plus 3x gives me 8x. And -6y plus 6y, well, that's just 0. And then -32 plus 48 will be 16. So really I just have 8x equals 16. Then I can continue to solve for x by dividing both sides by 8, and I get x equals 2. But you're not done yet. You still need to solve for y. You can go back up into the original equations and you can plug in x equals 2 into either equation and solve for y. I like to try to choose the equation without the negative numbers if possible. So I'm going to take the second equation, that's 3x plus 6y equals 48, and I'm going to substitute my x in here. So I'm going to get 3x will be 3 times 2 plus 6y equals 48. So that's 6 plus 6y equals 48. Then continue solving for that. Start by subtracting the 6 to isolate the y variable, and then divide by 6, and we get y equals 7. So my final answer is the ordered pair where x equals 2 and y equals 7. That is where these two linear equations, the two lines, intersect. That is where they are equal. Here's example 3. In example 3, I have them lined up. I have my x's, my y's, my operations, my 6 and 10. Everything's lined up good. But I don't have opposites. And so we have to make opposites using multiplication. So I'm going to try to eliminate my y's. And I'm going to do that because they already have, the signs are different. The signs are different already. I have one y that is positive and one y that's negative. So now I need to decide, well, what can I multiply by, 5 by, and 2 by, and get a common multiple. So if you think about when you count by 2's, 2, 4, 6, 8, 10, you know that they both have 10 in common. So I'm kind of stumbling over my words and explaining this. But they have 10 in common. So if I take the top and multiply the top by 2 and then take the bottom and multiply by 5, I'm going to get a 10y in each. So that's going to look like this. So I'm going to take the top and multiply it by 2, and I'm going to take the bottom and multiply it by 5. Now make sure you multiply everything in there by 2 or by 5. So the top will become 16x plus 10y equals 12. So make sure to multiply each thing. And the bottom is going to be 15x minus 10y equals 50. So now I have opposites. Once I have opposites, I add the two together. 16x plus 15x is 31x equals 12 plus 50 is 62. Then you can continue solving for y, and you get divide by 31 on both sides, and we're going to get x equals 2. Then you're not done, so you got to go back, and you can either use the equations right here, the original, or you can use the equations that you multiplied by because they are equivalent. So you can use either one. I like to just go back to the original equations. So I'm going to take that top one, 8x plus 5y equals 6, because the coefficients are smaller numbers. And then I'm going to take x equals 2 and plug it in here for x. And then I'm going to continue solving. So 8 times 2 is 16 plus 5y equals 6. Positive 16, so subtract 16 on both sides, and 5y equals negative 10. Divide by 5, and y equals negative 2. Final answer then is the ordered pair 2, negative 2. The point where these lines intersect is 2, negative 2. Okay, example 4. My equations are lined up. I have y on one side, the equals, then x, then the constants. So I'm going to try to eliminate the x's this time. And so I have a negative 2x here, so I need a positive 2 on the top. So I'm just going to take the top equation times 2, and then that'll give me 2y equals 2x plus 6. Since I want the bottom equation to be the same, I can either just times it by 1, or you just leave it the same. Y equals negative 2x minus 3, because it's already an opposite. It's already negative 2. I chose the x's because one was positive and one was negative already. Now when you add here, you get 2y plus y is 3y. And then 2x plus negative 2x is 0. 6 plus negative 3 is 3. 6 minus 3. Divide by 3 on both sides, and you get y equals 1. Y equals 1, I'm going to take that up to the top equation here. And we get y equals x plus 6. If y equals 1, then 1 equals x plus 6. Subtract 6 on both sides, and I get x equals negative 5. So I get my final answer is negative 5, 1, because my ordered pair is always x, y. Okay, in example 5, I don't have opposites, and I don't have a pair that is one's positive and one's negative. So here you can choose to eliminate either the x's or the y's. I think I'm just going to go with the x's. I have a 2x and a 4x. I know that if I take the top times 2, I can make it a 4x. Well, actually, since it is a positive 4 on the bottom, I'm going to have to multiply the top by negative 2 because I want it to be a negative 4x. So I'm going to take the top by negative 2 and multiply everything by negative 2. So that's going to give me negative 4x plus negative 2 times negative 3 is positive 6y equals negative 18. The bottom equation I'm going to keep the same, 4x minus 6y equals 5. Then I'm going to add these together. Notice that negative 4x plus 4x is 0. 6 plus negative 6y is 0. So on the left side, I get 0 equals, then negative 18 plus 5 is negative 13. Well, 0 does not equal negative 13, and my variables canceled, so, or they equal 0. So therefore, both the variables were eliminated. I get an untrue statement. So this is an example of no solutions, or no solution. That means that really these were parallel lines. These were lines that do not intersect. The answer I'm looking for, though, is no solution. There's no solution here. Okay, the last example. Again, we do not have opposites. We don't have one that's positive and one that's negative. So you can choose which variable to eliminate. If I eliminate the y or the x again, I have a 12x, so I can make the top a 12. And since the bottom's positive, I'm going to need the top to be negative. So I'm going to take the top times -3. And so on the top, I'm going to get negative 12x minus 15y equals negative 36. And then the bottom one stays the same. And this time you'll see that negative 12x plus 12x is 0. Negative 15 plus 15 is 0. So you get 0 on the left. And then negative 36 plus 36 is 0. So I get 0 equals 0. And that's true statement. So that means that this is many solutions. So all the points along these two lines are solutions to the equation. These are the same line. They intersect in all points. So just remember, first you need to line up the equations with like terms. Make one pair opposite using multiplication if you have to. Then add the two equations together and solve for the remaining variable. And then plug it back in for the other variable. Okay, thanks for watching. Variable.